All right, welcome back. We're going to be looking at primary trig ratios today. And we're going to start with using your calculator because we need to make sure it's working properly. And the first thing you need to do is you're going to put in sine 30 degrees. And notice this degree symbol. If you don't get 0.5, it probably means that you're working in radians. Or if you get an error, then it could indicate that you missed a bracket. It depends on your calculator. So, if you didn't get a 0.5 and you're in class, then I'd say raise your hand. Make sure that it says D or DEG on your calculator. If it says RAD or gradients, then it's trying to measure it in a different way. The other thing, let's make sure you also know how to find angles. Try and do cosine inverse of 0.71, and you should get 44.8, which is a degree. If you're not getting that, again, come find me in class and I will go through this with you. Alright, let's move on to the next slide, which is looking at primary trig ratios. Our learning goals for this lesson are to determine the relationships between the ratio of two sides of a triangle and the ratio of two corresponding sides in similar right triangles, and to find sine, cosine, and tangent ratios. And specifically in this lesson, we're looking at this here. Sine, cosine, and tangent ratios. For example, sine A is equal to the opposite over hypotenuse. Just to go into a little bit of explanation, this is a generic triangle. What I mean by generic is it is not a right triangle, but what you can see is how to label them. And this will become important when we get to the sine law, that when we represent angles, they are usually represented as uppercase letters, and the side length is across from it is a lowercase level, or lowercase letter. So capital B is the angle where lowercase b is opposite of that vertex or side or point, and the lowercase b represents the side length from A to C. And this is uppercase C, which is the angle C, and this here represents a lowercase c, which is a side length. So we're going to take a look further at this. This is how we generically look at labeling triangles, which will become a little bit more important in our future lessons. Here we go. We've got our trigonometric ratios, and we call them primary trig ratios. And notice that it's saying sine A, that's an angle. So you could think of sine, cosine, and tangent as angle eaters, where they always have brackets. And I always in class would say, well, those are the mouths of this function, and they eat angles and then they spit out a ratio. And those ratios are defined by these things here. Opposite over hypotenuse for sine, cosine is equal to the adjacent over hypotenuse, and tangent is equal to the opposite over adjacent. So what exactly do these mean? Well, just a quick recap. The side across from this right angle is always going to be the hypotenuse. And since we're looking from angle A, then the side that is across from it or furthest from it is going to be the opposite side. And the side that is running along it is the adjacent side and is not the hypotenuse. The hypotenuse is always the longest side of the triangle and it's always opposite of the right angle. Alright, so if we're looking at cosine A, then it would be looking across. It's going to be the adjacent over hypotenuse side, so it's going to be this value here over hypotenuse, which is this. And we have an acronym to try and help you learn this, which is SOHCAHTOA. So we're going to be using this in our next slide and applying what we've just learned. But every time that I go into any kind of trigonometry test, quiz, whatever it is, I'd always be writing this on my paper, SOHCAHTOA, because we're going to reference it quite a bit here. So here we've got this sine A, cosine A, tangent A, and when we look at this, notice that it is A that we're looking at. So here's A, and what I would do at the start of this is I would label these according to the sides. Just missed that. So this here is the hypotenuse. We're going to put an H. This here is the opposite side across from A. And this is the adjacent side. So O, A, and H. So sine A is equal to O over H, which is 3 over 5. Cosine A is equal to adjacent over hypotenuse. So 4 is the adjacent side over hypotenuse, which is 5. Tangent A is going to be equal to opposite over adjacent, so 3 over 4. It's also used for finding slope, you could say. We switch this up a little bit differently in this next set because instead of it being angle A, we're now looking relative to B. So that means our OA and H, we should erase those, and we're going to do it relative to angle B. So let's get rid of that. So now, at this point, I would encourage you to pause and try and figure out what these ratios are, and then you can unpause the video to see whether or not you got it right. According to angle B, this is now the opposite side. This is the adjacent side, and the side across from the hypotenuse is H. Sorry, across from the right angle is the hypotenuse. So let's try this again. If we're doing sine B, it's O over H, which is 4, the opposite side, over the hypotenuse, which is 5. The cosine B is adjacent over hypotenuse, that's 3 over 5. Tangent B is O over A, which is opposite over adjacent, so that would be 4 over 3. That's a brief introduction to what the ratios are. We're going to apply ourselves, and here we want to calculate the value of x. Notice here that it is always going to be relative to the angle. So we're looking relative angle. We have 30 degrees, and we're going to label it based on this. So across from A, we're going to put an O along the bottom, which is not across from the right angle, is going to be the adjacent side. This is always going to be the hypotenuse across from the right angle. And here's what I would teach my students. I would circle the pairs. I do not have a pair to circle. I do not care about O. I then look down at my SOHCAHTOA. Which one has A and H? Not this one. This one has A and H, which means I'm going to be using C, stands for cosine. I told you earlier that sine, cosine, and tangent are angle eaters. So cosine, I give it a mouth with the brackets, and it eats angles, and the angle that we've got is 30 degrees, is equal to A over H. So that's x over 50. This then becomes a solution of, or a problem of solving for x. This is just going to result in a number here. And so I got my trusty calculator. If I were doing this, I would do it in one step, but just to make sure that you're doing it properly, you should get 0.866, and that's rounded, is equal to x over 50. If I were doing this on a test, I would write, okay, this is division by 50, the 50 comes up and multiplies, 50 cos times cosine, 30 degrees. Depending upon your calculator, you're going to write this differently, and if you're struggling with it, I think a lot of students, depending upon your level, will have problems with this, but you should be getting 43.3. In this case, what it's saying is, based on this angle and this side length here, x, is 43.3 units. And whatever that means would depend on the question. I'm going to encourage you to pause at this point and try and do this yourself. Notice that we are doing this according to angle B. And I'm going to go through this now. Again, pause, try and do. This is where you will have the learning. So based on angle B here, we're going to label our triangle, OA and H. This is the opposite side. Across from the right angle is the hypotenuse, and beside it is the adjacent side. I'm going to circle my pairs. I'm going to get rid of the one that I don't care about, O and H. I look down at my SOHCAHTOA, which is on my paper, I'm using sine. So sine, open the mouth with the brackets, put the angle, 40 degrees is equal to O, that one always goes on the top, over H. So 30 over X. And there's a misconception is that sometimes people multiply or divide by sine. It doesn't work that way. What we do is we're going to switch the places here with the sine 40 and the X. The X comes up, the sine 40 comes down. And this is what happens when we end up having the X on the bottom. So this would become 30 over sine 40 degrees. X is equal to, using our calculator, it's going to be equal to 46.7. And that's a length, because we're finding the hypotenuse here. Moving on, we're going to take a look at how to calculate an angle. So this is, now we need to find the angle A, and it tells us which angle we're looking for. So if this is A, we're going to label our triangle based on that. O, H, A. Circle the pairs. Circle the pairs. We do not care about A, which means O and H, means we're using sine. Sine. The angle we do not have, but we are finding it, so we need to put angle A inside here, is equal to the opposite, which is 30. And we're looking down here at our trusty SOHCAHTOA. 30 over 50. In order to get this onto the other side, we have to do the opposite operation. A is equal to, when we bring this over, it's like saying if I said plus, you say minus. If I say minus, you say plus. If I say multiplication, you say divide. If I say sine, you would say sine inverse. It is not division. You do not bring it down. It's like it is an operation in its own. 30 divided by 5, sine inverse of that will spit out an angle. And that angle is, using our calculator, 36.9 degrees. And that's how you end up finding angles. Whenever you're finding an angle, use sine, cosine, tangent, inverse. I encourage you to pause it at this moment to try and do this one yourselves. We're finding angle B. I apologize because it did have A in red. Label it according to B. O, A, H. Circle the pairs. A and H, which means we are using cosine. Set up our ratio. Cosine of B, because that's what we're finding, is equal to A, which is 30, over H, which is 50. To get the cosine over, it is cosine inverse. B is equal to cosine inverse of 30 over 50. B is equal to, using our trusty calculator, it will tell us that B is equal to 53.1 degrees. And that is this angle here. If you're not getting the same answers I've got in these slides, or you're struggling with using your calculator, that is a common problem. Come and talk to me in class. I appreciate that you've taken the time to watch this video. You've got several questions to try and do. You got these questions. Practice will make perfect. Thanks for watching, and good luck on your studies.